Okay, continuing now with this section on exponents and eventually logarithms, we're going to look now at just the rules for indices and a review of them, because these would have been covered in previous years and particularly in year 10. We're just going to review them. Important for us now to get these in advance of learning some new work, and just remember where we're at with them. There are 4 of them that we're going to look at. Multiplication rule is this one here. So what I want to highlight is that when you're multiplying two terms, it's a to the m times a to the n in this case, we multiply them together. The base is the same. You see that? We've got an a here and an a there. So the base is the same. When the base is the same, then we can add the indices. And you see the result here is a to the m plus n. So when we have a look at some examples, then we've got sort of 2 to the power of 3 times 2 to the power of 12. The base is the same. Now here, importantly, have a look here. This doesn't say a squared. We don't take the a times the a and write a squared here. The base holds, so it's just 2 to the power of 15. Sometimes students here, when the base is not a or x or some letter, they want to multiply the 2 by the 2 and write 4 here. Don't do that. Just add the powers and hold the base. So that's 2 to the power of 15 there. Perhaps more straightforward almost when you're doing, say, x squared y cubed and multiplying by x to the power of 4y, because you just come underneath here and go, right, my base is x, have 2 and 4 as powers, so I'll add them, and my y base has powers 3 and 1, so I add those to get 4 in that way. Maybe have a look at another example with 2 as the base, with powers of x and x plus 2. Again, we just hold the base and add the powers x plus 2, so we get 2 to the power of 2x plus 2. And if you can do these ahead of me writing the answers, as I've said before, that's so much the better. In the last example here, we'll just bring in some numbers as well. So 3a squared b cubed times 4a cubed b cubed. And in this case, we take the numerical 3 by 4, 12, and then with the algebra, we add the powers of similar bases. So add the powers of a to get a to the 5, add the powers of b to get b to the 6, and it's as simple as that. Okay, our second rule is the division rule. A to the m divided by a to the n. Bases are the same. We subtract the powers, don't we? A to the m minus n. Okay, so that's all fine. We'll do a couple of examples there. So we'll simplify. We'll look at some examples. Okay, just pause there so to get the examples down. Okay, so we're going to use this quality now. Now what we've got here, x to the power of 4y cubed over x squared y squared. You can look at this as x. This is division. X to the power of 4 divided by x to the power of 2 is x squared. 4 minus 2, y cubed minus, so 3 minus 2 is just 1, y to the 1. The other way you can look at this is I like to remove the smaller of the two powers. When I've got the same base, I've got a power 2, power 4, I remove the smaller and I subtract the larger by that amount. Again, here I remove the smaller of the 3 is 1 greater than the 2, so I've got x squared y to the 1. It's the same as x squared to the y. So I'll go over here and do the same, except in this case, what I'll do is I'll add the powers in the numerator first. So I've got 4x plus x plus 1, so I get 5x plus 1 over b to the power of 2x. So what this is, I could put this into a division sort of format. This is the same thing, isn't it? And then I just do a subtraction of powers. So I end up with b to the power of 5x plus 1 minus 2x. The b holds. 5x plus 1 minus 2x is 3x plus 1, and so that's my result there. Moving over to C, again, I want to sort my numerator out first before doing the division. That's always the easiest way. 16 fours are 64. Adding the powers of a to the 9, adding the powers of b, because I'm multiplying, b to the 4. Now I'm dividing a b. If you want to have a look at it like that, the 64 goes 8 times, that goes to 1. This is a to the power of 1, so I remove that, and that turns into an 8. This is b to the power of 1, I remove that, that turns to a 3. So the result with 1 underneath is just 8a to the power of 8 b cubed. Now I'm sure you're okay with all that. Okay, looking now at the power of a power rule, or raising to another power, this is where you just multiply your powers together, so that'll be a to the mn. As an example, you could take 2x squared and raise that all to the power of 4, and what you end up with, you raise the 2 to the 4 to get 16, you raise the x squared to the 4, multiplying the powers out to get 16x to the power of 8. Now the fourth and I think last, fourth and second last, we're going to go to 5, is this product index rule, where you've got a product in here to a power. Now we can split that out to a to the n, b to the n. Okay, that looks like that. And while we're at it, let's have a look at a over b. Now when we've got a fraction raised to a power, it's often really useful to split that out as well. So that's a to the n over b to the n, really important, those ones. We'll look at a couple of examples now that use those qualities, those rules. So look at some examples. Firstly, 8 to the power of minus 2. Right, that's 1 over 8 to the power of 2, which is 1 over 64. Just a reminder there of the negative rule for indices is 1 over. Let's have a look at, say, a half to the power of minus 4. Now what this using rule 5 here, that's going to pull 1 out and put it to the minus 4. It's going to pull 2 out and put it to the minus 4. 1 to anything is 1. 2 to the minus 4 is 2 to the minus 4. 1 over 2 to the minus 4. Now, with a negative power, it becomes positive in the other part of the fraction, so that will just be equal to 16. Another way of looking at that would be 1 over 2 to the minus 4 is 1/16. 1 divided by a 16th. How many 16ths in 1? Just 16 of them, whichever way you want to go. Okay, have a look at another example. I'll just write this out. Okay, so in this example we're going to use primarily, we're going to use both 4 and 5. But let me show you but primarily 4 to certainly start things off. Now I've got bases of 3, 6, 12, 9, 2. This is not good, but what I can do is use this fella here, ab to the n equaling a to the n, b to the n. Let's just see how this works here. 3 to the minus 3, I'm happy to keep that because I reckon I can write my 6 as 3 by 2. So if I could almost get everything in 3's and 2's as bases. 6 is 3 by 2, so if I write it like that, and I write my 12 as 3 by 2 by 2. Okay, so you can see what I've done there, hopefully. My 9 is 3 by 3, and my 2 can stay because I'm just getting everything in 3's and 2's. Because if I've got the same base, I know I can use my add and subtract rules for multiplication and division. So now I'm going to take my brackets out. So I've got 3 to the minus 3, that hasn't changed. Look at this, 3 times 2, this is now my ab to the n, isn't it? It's 3 to the 4 by 2 to the 4. So you see what's happened there? Now over here I've got 3 to the minus 3 by 2 to the minus 3 by 2 to the minus 3. And now I've got a whole string of terms, but they've all got bases 2 and 3 now. Underneath, 3 to the minus 4 times 3 to the minus 4. Sorry, 3 to the minus 4 down there times 2 to the minus 2. So now what I can do is work with my numerator and my bases of 3 and just add the powers together because it's all multiplication. Minus 3 plus 4 is 1. Minus 3 is minus 2. So it's 3 to the minus 2 by 2 to the 4. Minus 3 is 1. Minus 3 is minus 2. So 3 to the minus 2 by 2 to the minus 2 over 3, what happened here? Now minus 4 is minus 8 by 2 to the minus 2. Okay, so they cancel each other out, and the 3 to the minus 2 divided by 3 to the minus 8 is 3 to the power of 6. You can think of that as 3 to the minus 2 divided by 3 to the minus 8, where you end up with 3 minus 2 minus 8, which is 3 to the 6. You can look at it that way, or you can look at it as I was looking at before, where you remove the smaller of the two and you adjust the larger to reflect how much larger it is. So in this case, minus 2 is 6 greater than minus 8, so this one goes. If I was doing it this way, I'd take that off and I'd put 6 in there. So 3 to the power of 6 is the result. Okay, just one more example now. Look, like with all these things, if you've seen enough examples and you just want to move and leave it at that, that's fine. You might, when you get into the exercises, when we do those in class tomorrow, you might find that going back into looking at these solutions might be useful for you at that point. So if you don't have any time now, that's fine, but they're here for your reference if you need them. Okay, again, we've got in example D, we need to get the bases the same. Now the 3 and the 3, I'm going to hold them. This 6 is going to become 3 by 2, and this 8 is going to become 2 by 2 by 2. So once I've done all that, I'll be able to, like I did in the last question, last example, I'll be able to combine my bases by adding and subtracting powers. You see what I'm doing here. So 3 to the power of 2n, that holds. Now this becomes 3 to the power of n by 2 to the power of n. That's all good. And underneath here becomes 2 to the n by 2 to the n by 2 to the n by 3 to the n. And tidying that up now becomes 3 to the power of 3n on top by 2 to the n, and underneath 2 to the power of 3n by 3 to the n. Okay, so what can we do about this? We've got let's go and do some slashing here. 2 to the power of n. Now this is, that can go, that's the smaller of the two powers. This becomes 2n. I'm subtracting the n from 3n. This is the smaller of the two powers it can go. That becomes 2n. So I'm left with 3 to the power of 2n over 2 to the power of 2n, which I could actually write as 3 over 2, all to the power of 2n. Okay, all roads now lead to exercise 15b, starts on page 417. I'll see you soon.